These are the solutions for the study guide for Chapter 5, Section 1. So let's take a look at our first problem. It says solve the system of equations by graphing. And so what I'm going to end up doing is I'm going to use the slope-intercept form here. So I see there's no number being added to x. So that means the y-intercept right here is 0. So I start at the origin and then use the slope to graph the rest of the lines. So the slope in front of this, or a slope for this number, for this equation, is 1. And so I can write 1 as a fraction as 1 over 1, and again, that's my slope. And so what I'll end up doing is just going up one space and 1 to the right each time. It gives me some points to be able to plot. And then I can also go the other direction. I can go down to the left as well. So I'll go ahead and just put points in for all these intercepts or on this graph paper that I have, so that I can see where the other line will end up crossing. That's what I'm going to do next. I'm going to go ahead and start with the y-intercept. So the y-intercept is positive 1. And so I'm going to start one space up on the y-axis, put a dot there, and then use the slope. And the slope of this line is 2 to 1. And so I'm going to end up going up 2 spaces and then over 1 to the right. However, I can only do that one time on this graph paper, and you can see how the line is getting further apart here as we go up and to the right. So let's go the other direction, down and to the left, and you'll see how they cross at this point right there. You see if you go down to the left again, we'll end up getting a little further away from the line. So this is where they end up crossing. So if I was to draw the lines in here, you'd see one line looks like that, and the other line looks like this. And that's where they end up crossing at this point. And so that's the point that you want to write down. So that point is one space to the left and one space down. So -1, -1. Put some parentheses around those two numbers to show that it's an ordered pair. Look at the next one. It says the cost in dollars and of maintenance of a canoe. And so the cost in dollars and maintenance of the canoe is C equals 15x plus 150. So what this means is the canoe costs $150, and then you have to maintain it and spend $15 for every value of x. So let's see what x is. X is the number of days rented. So $15 per day is what you're spending on the canoe, plus the $150. So Ed charges $45 per day to rent the canoe. And so we're supposed to write a revenue equation to start with. So there's our verb there. So our revenue equation, we're going to start with, before I get that revenue equation, I'm going to start with x, and x is the number of days. And then I'll have a cost equation, and the cost equation is given to me, so it's 15x plus 150. So $150. And then my revenue equation. So here's part of the answer right here. Revenue equation is $45 times the number of days. So x is days, so it's going to be 45x. So this is part of the answer right here. And from that point, we'll go ahead and fill in this chart. So this is the table that we're supposed to use. And so it says use a table to find the number of days of rental needed to break even. So let's start with 1 day, day 1. And so day 1 is going to be the $150 plus the $15. That's going to give us $165. For 1 day of rental, the revenue would be $45 because you get $45 each day. So we see those are not the same, so we got to continue on. So we have not broke even yet. So let's try 2 days. 2 days, we end up with $180 and $90 for revenue. So the numbers are definitely getting closer together, but not the same yet. So day number 3, we are now at $195 because I'm just adding $15 to the cost each time, because that's what it costs every day to run the canoe, and another $45 on the revenue side is going to give us $135. So we're still not the same. So let's try day 4. It's $210 for the costs of dealing with the canoe, of renting it out, and then we have to multiply 45 by 4, or just add 45 to 135, and that gives us 180. So the numbers are getting really close now. We're only $30 off. So let's try the 5th day. 5th day is $225 to rent the canoe, and 45 plus 180 also gives me 225. So this is the break-even point, when the cost equals the revenue, and that's on the 5th day. So now we've used the table needed to find the break-even point, so we found that, and now we want to say, what is the break-even point? What does it represent? Well, it represents at 5 days, the cost equals the revenue. The revenue is the income that you make from renting out the canoe, which is $225. So that's the last part of that problem. Let's take a look at this next one. It says the math club has 40 members. The number of girls is 5 less than 2 times the number of boys. So 5 less than 2 times the number of boys. We're supposed to do 3 things: write, graph, and solve for the number of boys and girls. So let's do this. Let's come up with some variables. We'll say we're going to go with B equals the number of boys. And how about G equaling the number of girls? And then let's go ahead and write the equation. So it says that the math club has 40 members. Well, the members are going to be boys and girls. So we're going to say the number of boys plus the number of girls is going to equal 40. Then it says the number of girls is. Is means equals. And so when I see that word, they're taking one of the variables, and so they say the word is, that's when you can just write G equals, and then write this expression, 5 less than 2 times the number of boys. So 5 less means I'm subtracting 5 from 2 times the number of boys. So those are my 2 equations. So now I'm going to go ahead and graph that. So I've come up with the 2 equations. I wrote the system, so now I need to graph. So I'm going to call this axis the number of boys. It doesn't really matter which axis you call that, but since I've got G by itself, that would make good sense to call this axis the y-axis the G-axis. And the reason is that I can use the slope-intercept form to go ahead and graph this. And so I'm going to go ahead and write down number of girls right there along the y-axis, or in this case my g-axis. And now I need to come up with some numbers, intervals for this. Now when I look at it, I've got 14 spaces here, so I could go by 2s, and that would get me up, well actually that wouldn't quite get me far enough, so I'd have to go up by 3s, which wouldn't make much sense since 3 doesn't go into 40. Or I could go by 4s, which would work out pretty well because 4 goes into 40, but when I look at this one, I'm going to start down at -5. So that's actually below my axes here. So using the graph, or going with the graph with 5s, would end up making a little bit more sense, since that works with both equations. So that's what I'm going to do. I'm going to call each interval here 5s, and so I'll just write in a few of these. So I'll do 10, 20, 30, and 40. And then I'll do the same thing along the x-axis, or my b-axis. So that's 10, and I've got 20, 30, and I've got 40 right here. And then I'll go ahead and graph that. So I know the first axis, or first equation, b plus g is 40. I could use the intercept method, and I could put 2 dots on the 40 on the g-axis and the b-axis, and that would end up giving me that line. Now when I do that, you see it's going to be a isosceles triangle, so it's going to go right along this line right here. So it's going to be somewhere in there where the 2 lines will end up crossing. And then over here I've got -5 for the y-intercept, so I'm going to start 5 spaces down, so I know it's going to be right about here, just 1 space down because each space is 5. And then I'm going to go up 2 over 1. Now I can do that because 2 to 1 is the same as 10 to 5. See, 10 over 5 is equal to 2 over 1. So I go up 10 spaces. 1, 2. That's 10 over 5, and that's 1 space. And so you can do that a few times, and you'll see where these lines cross. So right here is where they're going to end up crossing. So that's the point I'm looking for. So let's go ahead and highlight that point. And let's go down to the b-axis. And so let me get that to change color a little bit here. And so right here, right in between 10 and 20, is going to end up being 15. So it's going to be 15, comma, and then I go straight across, and that's at 25. 15, comma, 25. That's where the two lines cross. So 15 means something. 15 is the number of boys, since that's on the x-axis. So 15 boys and 25 girls is what we end up seeing there. So let's take a look at the next few problems. And on this one, it says solve using substitution. So when I substitute, I'm going to take that 5x and put it in for this y right there. So I've got 5x equals 2x plus 3. So I'll use some opposite operations. And I've got 3x equals 3. So I divide by 3, and I get x equals 1. So I take that 1 and I substitute that back into one of the two equations. That's probably the fastest one there. Y equals 5 times 1 gives me 5. So I've got an equation. My point is 1 comma 5. That's the point where the two lines cross. So they say check your solution. So I checked it in this equation already, so let's check it with this. So I just have to do 5 equals 2 times 1 plus 3. It's a good mental math check. 2 times 1 is 2, plus 3 is 5. And as I was doing these problems beforehand, that's what I did. I substitute. I want to make sure I did it right, so I put 1 back in for that other equation that I hadn't substituted into yet, and then did that to see if I got an equality, and I did. 5 equals 5, so I know it's right. So I'm moving on to this one. I'll substitute this expression right here in for y in the equation above. So I've got 4x plus 2 times by 1/2 x minus 5 equals 0. So I got to take 2 times 1/2 and 2 times 5. So 4x plus 1x, half of 2 is 1, minus 10. And so from there I'll go ahead and add the 10 to both sides. Collect some like terms here. So I've got 5x equals 10, divide by 5, and we've got our answer. X is 2. So I take that value and I substitute back in. I'm going to put it in for this bottom equation there. Y equals 1/2 times 2 minus 5. Again, you can do a mental math check here, and it's always good to do that just to check and see if you're doing it right. So y is negative 4. So I got 2 negative 4. So let's do that mental math check. So I'm going to take that 2 negative 4. So that's what I got with the bottom equation. Let's put it into the top. I know it works for the bottom because that's what I substituted into, and that's what I got. So if I go ahead and substitute 2 negative 4 back in the top equation, if I get an equality, then I know I did it right. So 4 times 2 plus 2 times negative 4 should equal 0. And so I do the work. 8 minus 8 is 0, yes. So when I get that equality, that means that I do have the true answer. You spend $56 on food and clothes. You spend $18 more on clothes than food. Write, solve. Those are the two things we need to do to find out how much you spend on each. And so we're trying to write a system and then solve the system. So we first need to define some variables. So let's say f equals the number of dollars. Well, how about we just say dollars spent on food. So dollars on food. And we'll say C equals the dollars on clothes. And we can write the first equation. F plus C. Since we spent money on only food and clothes, and we spent $56, those two add to make 56. Then they're comparing clothes to food. So we're going to start with C equals, and it says that you spent 18 more on clothes. So we have the amount spent on food plus 18 is going to equal the amount on clothes. So this is my system. We wrote the system. Now let's go ahead and solve. So it's a great substitution problem. I'll take the f plus 18. That goes in place of c. So it's going to be f plus 18 equals 56. So I'll go ahead and do some subtraction there. Subtract the 18 from all sides. That was a subtraction sign there. And when I do that, I got 2f equals, and that ends up giving me 38. So again, if you borrow, you'll be able to see that a little better. And when I do that division, 2 goes into 38 19 times. So let's go ahead and substitute back in. 19 back in for the f right here to find c. So c equals 19 plus 18. Remember, you spent $18 more more dollars on clothes than food. So when you go ahead and add the $18 and $17, you get $37. And so there it is. So we'll say $19 on food, and $37 on clothes. So let's move on to the last three problems here. And it says graph using intercepts. So when I'm using intercepts, I'm setting x equal to 0, and when I do that, cover up the x term, I'm left with negative 2y equals negative 2. You divide by negative 2, and we get our answer. So y equals 1. So this point is 0, 1. That's the y-intercept. So I start up one space. Now I'm going to set y equal to 0. And this one's nice because you're just left with x equals negative 2. So you got the answer. Negative 2, 0, that's where the line crosses the x-axis. And then you draw the line between those points. So in the next one, it says, what is the length of NP? It tells us that the two decks are identical. So I go down to NP. It's not given to me. So that means I need to look at the other one since it's identical and look for the corresponding side. FE is corresponding, so it's 3 feet. So 3 feet, because we'll say NP corresponds to, and then it was FE. And so moving on to the next one, AB and C is congruent to CD. So AB and CD are the same. What is the length of AB? Well, I look over here to find the corresponding side. It's not given to me. But CD is congruent to AB. So that means JK and LM are the same as well. So I'm going to say it's 6 feet. Or actually, yeah, it's 6 feet. 6 feet. And the reason is because it corresponds to LM there. So if that's the case, this is 6 feet. This is 6 feet. And again, because it corresponds, or we'll say CD corresponds to, and then LM. So now we need to find the perimeter. So let's go ahead and look at all the sides that correspond. So we've got 2. This is 2, 3. I'm missing this one, but it's 2 feet right there. And that's it. So let's go ahead and add them up. So we got 6 plus 2 plus another 6 plus 2. So I've done these 4 sides. So I'm going to mark the sides that I've done to make sure I've got them all accounted for. So I have 3 and 2. 3 and 2. So I'll mark those 2. And then another 3 and a 2. So one more 3 and one more 2. So let's count the sides again. 1, 2, 3, 4, 5, 6, 7, 8 sides. I got 1, 2, 3, 4, 5, 6, 7, 8 numbers. So this is 8 and 8. And this is 5 and 5. And so that makes 10 and 16 gives me 26 feet. So moving on to the last one, it says the cost Y in dollars for making bracelets is, and then this is the equation. So we'll go ahead and put down Y is the cost, that's this axis, and then this axis over here is the x-axis, and it represents number of bracelets. So let's write that down, number of bracelets. And so what they want us to do is graph this line on this. But we've got to first make sure we label our axes, which we did. And we have to number it as well, number the axes, or the intervals here. So I'm going to go by ones. The reason I chose that is because we have small numbers here. We're going to start at positive 2 on the y-axis. So it looks like we can fit everything here. So I'm just writing every other number just so I don't clutter up the axes, and I'll start at positive 2 and use the slope. Now 0.5 is the same thing as 1 over 2. So I can go up 1 over 2 spaces, up 1 over 2. And that's why the fraction form is sometimes nice to use. So you can go up a half and over 1 space, and you see how you do get in between that line. And so that's kind of what the line ends up looking like there. Then they ask me how many bracelets can be made for $10. So I can substitute. That's one way to do it. So 0.5 of 10 plus 2. Well, half of 10 is 5 plus 2 makes 7. So 7 bracelets would be my answer there. But you could also use the graph. So let's take a look at that. I do have 10 on my graph. I could go up to this point right here. It looks like it's going to cross right there, and then straight across is going to be right in between 6 and 8, which is 7. So $7. Actually, let's see how many. Oops, it says, see right there, I figured I made a mistake. And so we need to substitute 10 in for y, not x. So let's go ahead and fix that real quick. I was thinking that was bracelets there, and that ended up messing me up. So it's good I checked using the graph, otherwise I would have had a problem. That's why it was nice for me to label that, otherwise I definitely would have made a mistake. So 10 in for y. So how many bracelets can we make for $10? Okay, $10 is going to be up here, and it's going to be off my graph. So let's go ahead and fix that. And so I've got to go ahead and plug 10 in for y, and I've got 0.5 x plus, and then the $2 for the starting cost. So I subtract the 2, that gives me 8 equals 0.5x. So when I divide by a half, I end up having to move that decimal point over one space. Do the same thing here, move that over one space. So I really have 5 into 80. And so when I do that, 5 goes in 8 one time. With 3 left over, it goes into 30. We have 6 times, so it looks like 16 bracelets is what I can end up making there. So those are the types of problems that you're going to end up seeing on your test. Good luck.